Assalamualaikum. My name is Nur Madiha. Cyclone separation devices that use the principle of inertia to remove particulate matter around 5 to 10 micrometer. Smaller particle that escape the cyclone can then be collected by more efficient control equipment. Cyclone more applied in several disciplines such as environmental engineering to remove particulate pollutant, chemical engineering, and mechanical engineering to collect valuable particles in working environment, and lastly pharmaceutics to classify their powder drugs. Removal efficiency of a cyclone for a given size particle is very dependent on the cyclone dimension. The overall length determines the number of turns of the vortex. Greater the number of turns, the greater the efficiency. The length and width of the inlet are also important. Since the smaller the inlet, the greater the inlet velocity becomes. A greater inlet velocity gives greater efficiency but also increase the pressure drop.
There are several advantages and disadvantages in using cyclone separators. First, cyclone separators are beneficial because they are not expensive to install or maintain, and they have no moving parts. This keeps maintenance and operating costs low. As well, the removed particulate matter is collected when dry, which makes it easier to dispose of. Finally, this unit takes up very little space. Although effective, there are also disadvantages in using cyclone separators. Mainly, the standard models are not able to collect particulate matter that is smaller than 10 micrometers effectively, and the machines are unable to handle sticky or tacky material. The efficiency of the cyclone can be calculated by using the equation, which is efficiency equal to weight of sample collected in dust hopper divided by initial weight of sample in feed container minus with final weight of sample in feed container, and then multiply by 100.
Assalamualaikum. My name is Siti Hajar binti Dahlan. I will explain to you about the mechanism of cyclone separator in the lab. So basically, the cyclone separator consists of inlet and outlet sections, the cyclone body, particle discharge system, and the hopper. So how it works? Dirty gas that contain particulates entering the cyclone with the aid of centrifugal force. So this will form a helical pattern inside the cyclone body. Due to supply of centrifugal force, large particles inside the cyclone body inside the dirty gas crash into the wall and settle down by gravitational force into the hopper. As the gases being constrained at the smaller diameter of the cyclone body itself, the vortex reversal occurs by which the gases travels upward to the clean gas outlet. Thus, the fine particles also being exhausted out of the cyclone, and the large particulates are collected in the hopper.
How the exploration look like.
This is the cyclone simulation that extract from the internet. The simulation shows how the particulates entering the cyclone and formation of helical pattern. Dark blue particles indicates the large particulates, while the light blue particles indicates the fine particulates. As the particulates reach the bottom of the cyclone, there will be the reversal of the vortex that force the fine particulates to exhaust out of the cyclone together with the clean gas.
entering the outlet's dust filter. Make sure all items and connections are assembled and tightened properly before starting the experiment. Prepare the experiment for 100mm cyclone operation. Read separately the empty feed container and dust hopper. Read 50 grains of sample and pour slowly into the feed container. Attach the feed container to the holder and adjust so that the outlet of feed container is just inside the inlet piping of Cyclone. Switch on the main switch and push the start button to run the air blower. Adjust the inverter controller to achieve inlet air velocity around 19 meters per second. Switch on the computer, which is it will direct launch the DAS software, and then click the experiment button and choose experiment A1. Click the record button to record the airflow rate and pressure drop. Run the experiment for 30 minutes. switch off the air blower after the experiment is completed. Detach the feed container and the dust hopper and weight them separately. Determine the collection efficiency of the cyclone by key in the weight of sample loaded and collected. Repeat the experiment with the 70mm body diameter cyclone.
My name is Muhammad Kayum. Today I'm going to talk about the factors that affecting the efficiency of the cyclone. Okay, the first factor affecting the cyclone is the diameter of the cyclone itself. Where the diameter affect through the size of the diameter. So meaning the smaller the diameter of the cyclone, the more efficient for it to collect the dust particle. And then the second point is the length of the cyclone, where the longer the length of the cyclone, the more efficient it will collect the dust particle, as it will produce more vortex, and then the more heavy the particle, it will go down, and then the lighter will go up. Okay, for the third point is the pressure. The higher the pressure, the more efficient for the cyclone to operate. Because if there is not supply enough pressure for the cyclone will not work properly, as it cannot produce the vortex. The vortex produced is important to separate the dust particle and to treat the dust particle itself. And last but not least is the particle size. The particle size also affect the efficiency of the cyclone itself, where the smaller and the lighter the particle, it will affect because it will not so efficient, as in the cyclone itself. It spread the through the weight of the particle itself. When the dust particle is lighter and smaller, it cannot follow the vortex, but it will goes up and go to the vent system, where it will release to the environment. That's all for my part. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Mirza Azib bin Muhammad, and I will proceed to the recommendations to improve the performance for our cyclone system. Okay, first, we have to increase we have to decrease the size of the diameter of the cyclone. This is to ensure all of the particles can be collected on the wall of the cyclone. Thus, the particle collection efficiency will increase. Okay, next is about the pressure. As said by my fellow colleague Muhammad Qayyum, we have to increase the pressure of the system. Therefore, this will develop faster vortex, and also eventually increase the efficiency. So next is about the flow rate. To fully develop the vortex in the cyclone, you have to have a significant amount of flow rate. Therefore, with higher amount of flow rate, this will eventually have stronger rotational vortex in the cyclone, thus increasing the collection efficiency. Okay, and also there are some other recommendations that we can put to improve the overall system, our cyclone system, which is we have the general startup procedure must be done properly. We have to ensure that all the equipments and parts of the system are properly function. This is to ensure that the experiment or the system are not being disturbed when being operated. After that, we have to also have higher precaution when measuring the weight of the samples and other required equipments. This is to avoid any mistakes for the before and after weight, measuring weight of sample and ensure higher efficiency of collection. And also lastly, we have to also and lastly, when using the computer system to gather the results, make sure to make it done in precise time. This is to ensure that all the overall results are being taken in exact time and precise. Thank you.
Here is a video of a reverse flow gas cyclone in operation. The outer vortex can be clearly seen pushing the separated solid particles towards the lower exit. The gas leaves via the top exit. And here is an animation showing the cyclone's operation.
Okay, cyclone test number 1. Going to put some paper scraps through the cyclone so you can see it going. Okay, cyclone test number 2, we've got some router shavings, etc. And we've added a pipe on to suck the router shavings out, and we'll see how that goes around. Okay, so the top's off. Can't really see it in this light, but a lot of the finer dust down the bottom there. Some of those router shavings fell in from the top up here, but I think that's pretty good. We'll do a bit further testing once I empty out the extractor bag, and we'll be able to see how much of that actually goes through into the extractor. Okay, we're back for test number 3. Now what I've done is I've actually cleaned up the dust extractor as best I can. Got the air hose onto it and blew most of the dust out of it, out of the bags and that. Now, I'm not going to show you the vacuuming up for this stage. Basically all I'm going to do is just go around and get all the fine dust that's slowly built up since our last cleaning. That is built up obviously because the dust bag separating the fine dust is pretty much useless now because the bags are fairly old, and to be honest I don't think they were that good to start off with. So anyway, I'm going to hook up the larger hose off our CNC machine to the Cyclone, okay, and I vacuum up as much fine dust and that as I can find around the shed, get the shed nice and clean, and when we come back we'll check inside the dust extractor and see how well it went. Okay, we're back after giving the shed floor, etc., a bit of a rough clean down. I could have done it a lot better, but I don't want to be spending all day in here now. I've got a bit of debris in the bottom here. It's picked up things from, as you can see, that pink post note around the side here, sawdust, bits of sandpaper, etc., so has no problem picking anything up. At first look, I can see a little bit of fine dust has actually made it past the Cyclones. How much we won't know until we look inside the extractor, so not 100% impressed with that, but it might be a lot less than it looks, judging by there. Okay, so give me a sec, I'll chuck my dust mask on and we'll have a look inside. Okay, so we're back, we're looking inside the bin. Alright, quite a bit of fine dust has gone in there, so that's pretty good. As I mentioned before about the seals, okay, needs to be a good seal. There appears to be a light leak just there. We might need to fix that up, but the rest of the seal around the edge seems to be quite fine, so that'll need a bit of fixing up and we'll get it operating a bit more efficient now. Let's take a look inside the dust extractor bags. Okay, so I've taken the dust extractor bag off. Alright, it's a bit hard to tell in this bag, but looks relatively clean. Okay, got a little bit of dust, not that you could probably see that, on the inside there. Okay, so we still need to fine tune that seal bit up a bit, but other than that I reckon it's been pretty successful.